This is the third video for the 6-2e lesson. We're going to start to look at higher roots. Now we're going to look at a fourth root. So we're going to be looking for four of a kind. So we're just going to factor tree. You can think of your cube roots as a way to maybe consider if something is a fourth root. I wouldn't go about necessarily memorizing numbers that are perfect fourths or whatever they're called. There is four of a kind, so out comes a two. Next, it says explain why the fourth root of negative 81 has no solution. Well, we kind of know based on square roots that we're looking for four identical factors. And although 81 is actually a perfect like fourth number, 3 to the fourth is 81, there's no combination of identical threes that is going to work, right? If we make them all positive or all negative, it's not going to equal negative 81. Remember I mentioned I prefer to call these no real root. And so similar to square roots, you might scan some problems and see if you have an even index and a negative radicand, don't even bother doing it. Just write no real root. We're going to look at a couple more. If you think you got the idea of roots and higher roots, you feel free to pause the video or skip ahead or try some of these, or if you want to just watch them. We're going to look at simplifying the fifth root of 96. So we're going to look for a 5 of a kind. And we're just going to start breaking this up. This will obviously require 2 times 2 times 2. I'm just going to jump to that. Having an organized factor tree, carefully identifying a 5 of a kind. Maybe circling no longer works because they're maybe farther apart. Out comes 1, and the 3 is going to stay inside. So 2 times the fifth root of 3. Then we're going to do the sixth root of 192. Well, the sixth root of 192 cut in half is 96. So we can kind of use the previous factor tree without having to redo all of this. And so 96 was 2 times 2 times 2 times 2 times 2 times 3. It had 5 2s. All right, so now we have a 6 of a kind. That's what we're looking for here. Out comes 1 representative and a 3 all stuck inside. We're going to start to look at variables with this. Similar to variables on other ones, these might be a bit trickier and there are some shortcuts, but if in doubt, start by just expanding it out. We're going to write out 5 and we're looking for a 4 of a kind. Out comes 1 representative, and one of these is stuck inside. All right, and as you look at that, you might start to see some sort of shortcut. And we're going to look at another one. And this one said explain, but I think my work does a good job explaining that. Look at one more with higher exponents, different exponents. So sixth root of x to the 8th, y to the 10th. So first option is maybe you just expand this out. Another option is you can start to think about this. How many kind of 6 so of a kind, so to speak, are there in x to the 8th? Well, there's definitely 1, and there's definitely going to be some left over. There's going to be 2 left over. And in y to the 10th, there's going to be 1, and there's going to be 4 left over. So we could clean this up and make this xy, 6th root, x squared, y to the 4th. Another option as we think about this is, again, kind of proving how I figured this out by just writing out. That's 4. There's 8. So here was 6 of them. and then 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's 3. And I think I got the right number. Cool. So I'm extending obviously the Radican, but doing that is worthwhile. There probably won't be too many crazy variable ones. Maybe just expanding them out's a good idea. Thinking about it in your head, and maybe trying to figure out what the shortcut is, which in the last video of this lesson, I'll mention that if you have yet to figure that out.